Hi everyone, this is the gas walkthrough for June 3rd. I'm Philip Newman. Today I'm solving Tilting X-Windmill by me. Clover has been sick. I filled in for her on the June 1st post. She did post a puzzle on the 4th, but wasn't feeling up to recording. So I'm filling in for that this time. This is another variant that I was totally unfamiliar with. I have thought about Latin squares that are tilted in a grid before, a long time ago. But this specific variant is new to me. It was mentioned in the Theory and Programming channel, and I spent some time looking for a minimal version of this, and then decided to make a gas. So that's what this is. We have normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. Additionally, we have these gray cells in the grid, and they form a Latin square, a 5x5 Latin square that is tilted at a 45-degree angle from the Sudoku grid. So all a Latin square is the row and column restraints without the box constraints. So it is a grid of digits such that the same 5 digits appear in each row and column without repeats. And that's it. That's basically it. So we do need to keep in mind, in addition to no repeats, so we have a 7 here, none of these cells can be 7. None of these cells can be 7. We also get the Sudoku rules. None of these cells can be 7. In addition to that, we need to use the same 5 digits in these cells, etc. So those are the rules. And because this is gas, I've given you a little bit of a head start in that we have 4 of the digits that appear in the Latin square. We don't know what the 5th digit is. I will pencil mark the possibilities. It can't be 1 or 9. We already have 3, 4, 6, 7. So it is 2, 5, or 8. We can't resolve that until we do more with the Latin square. So even though we don't know what all 5 digits are, we do know what 4 of them are. And we know those 4 digits must appear 5 times in the Latin square, once in each row, once in each column, or vice versa, whichever way you tilt your head. So let's look at this first. Where does 3 go here? There's a 7 already filled in there. Can't go here in the box, can't go here in the row, can't go here in the Latin square. So this is the only place for 3. 7 down here. Can't go in this cell because of the Latin square. This cell, the row, this cell, the box. So this is 7. And you'll notice the symmetry here. This is another one of my puzzles that has this X-Windmill symmetry. I don't know who came up with that term. Lucian uses that in his solve videos all the time, so that's where I picked it up from. But the idea is that the low digits are mirrored by the high digits rotationally. So every time we have a 1, we have a 9 rotationally opposite. Every time we have a 2, we have an 8, 3, 7, 4, 6. And this is a useful thing for constructing sometimes. It makes pretty puzzles, because you end up with things like 1, 2, 3, 4, 6, 7, 8, 9. Stuff like that. It comes up in variants like German whispers, Rinban, where the high-low doesn't matter so much, but the relationship of the digits is symmetric in that sum to 10 sort of way. So anyway, every time we deduce something about a low digit, we're going to have the same deduction about high digit, and vice versa. We don't need to use the uniqueness part of that. We do know this is a 5 because this puzzle is unique, but we're not going to use that. Anyway, there are a couple other places we can look. The next place I want to look, though, just because it's a different type of deduction, what we just did, these are hidden singles. We had a row or column. We had this diagonal of the Latin square, and it needed a 3, and this was the last place 3 could go. This was the last place 7 could go, here. We can do some more with that, but the other type of deduction that's kind of the most basic deduction that you can make in Sudoku is called a naked single. And so that's where we're asking what digit can go in this cell. It's limited to only one possibility. It's not whatever the central digit is. It's not 3 in the row, and it's not 4 or 7 in the Latin square, so it must be 6. This digit sees 3, 6, 7, and the central digit, so this must be 4. This now can't be 6 or 4, it can't be 3 in the row, must be 7, and this must be 3. So that gives us some more digits. And now we can do some more hidden singles. Where does 3 go in this? Sees that 3 in the box, so it must go here. Likewise for 7 in this one, it sees that cell in the box, and it sees that cell on the diagonal, so this is a 7. We have now 4 of our 7s in the Latin square. The last one needs to go here, and then our 3s, the last one needs to go here. This cell can't be 3, 6, 4, or 7, so it's going to be our mystery digit. I'm going to highlight these. Same over here. And that means this is going to have to be 4, this is going to have to be 6, this is going to have to be 4 and 6, like this. This now is our mystery digit, and so is this. And finally, this is 4, and this is 6. So now we've got all of the Latin square filled in, except we haven't resolved what this digit is. But now that we know where it is in the Latin square, we know it can't be 2, and we know it can't be 8. So it must be 5. And that's the Latin square resolved. So we are done with the variant. Now we're just doing classic Sudoku. So in this column, we need 2 and 8. That's going to leave 1 and 9 here. That's going to leave 2 and 8 here. Let's look for singles before we get carried away here. 3 in this box must go here, and that means we're going to have 7 here from these 7s. What other 7s? 7 is going to have to go here in this row. 7 is going to have to go here, and I think that's all the 7s. Then we're going to get a 3 here from these 3s. We're going to get a 3 here to finish off the 3s. 4 up here, because of these 4s, must go here, and must go here in the box. Must go here in this box, and finally here. That's all the 4s. And then 6. 6 is going to go here in this box, here in this box, here in this box, and here in this box. And that's all the 6s as well. All right, so we've finished 4 of our digits. What about 5? 5 now can't go in these cells or this cell, so this is 5, and this is going to be the same all the way around the grid like this. Another windmill sort of pattern. So that is 5 digits. Let's look at 1. 1 has to go here. 9 has to go here. These are 1 and 2, and we know the order from this one. These are 8 and 9, and we know the order from the 9. This is still a 2-8 pair. And these aren't 8, so this must be the 8, 2, 8, and 2. This is 9 and 8. This is 9 and... got a 1-2 pair here, not yet resolved. This is 1 and 2. This is an 8-9 pair. This is 2. These are 8 and 9. These are 1 and 2. This is an 8. So now this 8 looks up here for 9, 8. It's going to give us 9, 1, 1, 2. And then here we had 1, 2, that 1 there, 2, 1, 2, 8, and finally 8 and 9. Oh, and I missed a 1 there. And that is the solution. So really a two-part puzzle. The tilted Latin square is kind of its own mini puzzle, and then you have a Sudoku at the end. I really enjoyed making this and the other couple of puzzles that I made with this variant. So I hope you enjoyed it as well. Let us know how you did in the comments, and I will see you next time.